Welcome back. In this video, we're going to explore the area of triangles. As with our earlier geometry formulas, we do not want this to feel like a formula that appears out of nowhere. We want to understand why it works. The formula for the area of a triangle is 1/2 base times height. But where does the 1/2 come from? Where does the base and height come from? Let's investigate. Here we have 3 different triangles, an equilateral, an isosceles, and a scalene triangle. And we're going to take 2 copies of each of these triangles. And the key idea is that in each case, 2 copies can be arranged to make a parallelogram. If we take a triangle and place a congruent copy next to it in the right way, like I've done here, the 2 together form a parallelogram. This works for our equilateral, our isosceles, and our scalene triangle. Once the parallelogram is formed, we already know how to find its area. The area of a parallelogram is base times height. But this parallelogram is made of 2 congruent triangles. That means each triangle has half the area of a parallelogram. So the area of one triangle must be 1/2 base times height. This is why the formula works. Now, let's pause on an important detail. The height is the perpendicular distance from the base to the opposite vertex, or to the line containing the opposite side. So here, this dotted line that I just drew would be my height. Same thing for this one here. But this one over here, I would actually draw it down to the extended side to get my height. In a right triangle, one leg may serve as the height. In an equilateral or isosceles triangle, the height may fall neatly inside of the triangle, but in our scalene triangle, the height may be less visually obvious, but it's still that perpendicular distance. This is an important point for future teaching, because students often want to multiply 2 side lengths they see, even if one is not the height. So it helps to ask, which segment is perpendicular to the base? Where is the actual height? Can we picture the full parallelogram made from 2 copies? Let's connect this to our 3 triangles we have here. For an equilateral triangle, the 2 copies fit together very symmetrically to form a parallelogram. For an isosceles triangle, the same basic idea works. 2 congruent copies create a parallelogram with the same base and height. For a scalene triangle, even though the shape looks less familiar, 2 copies still form a parallelogram. That is a very useful teaching point. The formula does not depend on whether the triangle looks neat or symmetrical. It depends on the geometric relationship. Excellent work. This is another example of a formula growing naturally out of a visual argument. Understanding that reasoning will help you explain area in a much more meaningful way to students.